Okay, so welcome to Euron everyone and welcome to this lecture of a computer vision. So this is going to be a introduction lecture for a computer vision. I'll be talking about like what computer vision can do, what kind of a capability that computer vision have, what kind of things that you will be able to build, and what kind of example or like what kind of a task that you will be able to do, what you will be able to solve with the help of computer vision. Obviously the opportunities are infinite, and if you will go to GPT or if you will go over a Google, you will be able to find out a lot of options over there. But yeah, so even here, so I'll be talking about a lot of options with respect to a computer vision introduction. So let's talk about that, guys. So here, let me share my screen first of all. Yeah, so I believe my screen is visible to all of us now. So first of all, what is this computer vision, by the way? So in a layman manner, if I have to give you an example that what exactly a computer vision is, so maybe I'll try to do a comparison with a human. So a human eye, the way we used to see something, the way we used to like see some sort of a scene, some sort of an incident, or maybe anything that comes in front of us. So computer vision is just like a human kind of a intelligence where it will be able to take a image and a video or maybe a real-time stream as an input, just like we as a human being does, and based on that it is going to take a decision. For example, so even nowadays autonomous car, self-driving car is pretty much popular, and we as a human being are driving a vehicle, driving a car since like many decades, I would say, right? Many decades. So how do we do that? So basically we have a eye, we have a different like input sensors, eye, and like we have a ear, we have a nose. So we keep on taking a different kind of inputs, and based on those inputs we try to process it as a human being, and then we try to take a decision. For example, if I'm driving a car and if something comes in front of my car, so obviously I'll try to apply a brake, right? So we see something, so basically we are trying to capture some sort of a streams with the help of our eye, then our brain is trying to process it, and then we have learned that in this situation, in this kind of a situation, we have to apply a car, no, sorry, we have to apply a brake. And whenever we see an empty road, so obviously we try to like speed up the car. So this is how our brain has been trained, this is how our entire body has been trained. So even we are able to take a decision just by looking at something, just by taking some sort of a image feeds, just by taking some sort of a video feed. So in the similar manner, so machine, if machine are going to take a decision, now that is called as computer vision, right? A computer which can see. Now, so like self-driving car is one of the example that you will be able to find out. And nowadays on almost every airport, or maybe on almost every like uh, I would say offices, and even schools and colleges, right? They are trying to adopt a facial recognition based attendance system, which is one of the most authentic one. Even in your mobile device, you will be able to find out a facial recognition system, so which can lock unlock your phone based on your like a face features. Basically it learns something based on the face features. Many people are using a facial recognition as an input for authentication, just like we had or we usually like use user ID and password. So now our face became a password, right? Maybe for a home automation, even for a multiple website, even for a multiple bank verification. So everywhere, right? Everywhere we are using these kind of a solution nowadays. And now it's not like sounds like a fancy stuff. It's like a pretty much like a regular stuff that we are trying to consume. So these are the things which comes under computer vision, and these are the problem that we will try to solve, or we are solving under a computer vision. So where we try to take our input with the help of a camera, we try to take our input with the help of a sensor, we try to configure it in such a way that it will be able to classify, it will be able to detect, it will be able to segment, it will be able to track, and based on that we can try to ask a system to take some sort of a decision, right? This is an area called as computer vision. Now, so if I'll talk about application, right? So applications are like not in thousands, I would say, but in a millions. So application of a computer vision. So I'll try to write down a couple of application over here. So face recognition is obviously one of the application which has been used widely, because there are 800 a crore people, or I can say there are 8 billion people exist on this planet, right? And obviously there are almost every day we try to do a lot of activity with respect to authentication, with respect to a violation, and many things, right? And everywhere face is important. Face is your signature, face is your identity at the end of the day. So just imagine how many use case you will be able to build just out of the facial recognition. And we have seen that, right? So for a schools, for a colleges, for a theft, or for a security and surveillances, for a authorization, for authentication, everywhere. So we generally use a facial recognition. Face is your unique identity. Now the second most use cases, maybe from a BYD and maybe from a Tesla, you must have seen a autonomous car, which is one of the famous one across a world, right? A Tesla car or BYD cars. And there are now multiple other vendors or multiple other companies who is trying to develop a self-driving car capability and features. So self-driving car is one of the again advanced driving. So now self-driving car is not just a part of Hollywood movies. Basically it's a reality, right? It's a reality where we can see a self-driving car driving us from one places to another places. Now, so the third application that you will be able to find out is a medical imaging. So over there, we try to analyze our X-ray report, our MRI, or maybe we try to do a tumor detection, maybe we try to do a fracture detection. All of these applications now we are building, and actually we are using it, right? We are using it, which is helping us in terms of taking a faster and faster decision in a medical field. Now these are just a 1-2 application, but there are tons of other application which you will be able to find out. MEDICAL, medical imagining. Now the fourth application which I can talk about is maybe a retail application. Retail application wise, so people counting, or maybe a theft detection, security surveillance, all these things comes under retail. Now not just this, even agriculture, right? So even agriculture is not like a field which is not using this one, right? So even in agriculture extensively we are trying to use this computer vision technology in terms of a plant disease detection, or maybe a estimation for a particular yield, right? So everywhere you will be able to find out, so whether it's a road or it's a agricultural land, or maybe it's a advanced airport, everywhere you will be able to find out an application of a computer vision. And that's the reason, so there are a lot of opportunities which is coming up on a regular basis with respect to just a computer vision. Now, so when we talk about a computer vision, right, so there is something called as a traditional computer vision, and there is something called as a modern computer vision. So what is the difference between this traditional? So again, it's not very much important, but still I would like to talk about it, that in case of a traditional computer vision, so we were able to build a solution, we were able to build an application based on a rule based filtering, even including a facial recognition. So we have seen that we used to build a rule based file system, and based on that, so we were trying to do something. But in a modern approach, so we try to train the model. So we have a lot of amazing network architecture which is efficient enough, if I'm going to train it with the enough amount of data and with the enough fine tuning, that it will be able to do a task automatically. So the previous one was mostly a rule based, but nowadays the system that we are using is basically a modern, a training based approach that we are trying to use. So this makes the new system, the upgraded system, highly adaptable across our industry. And in an older a traditional computer vision, so we were using just a OpenCV or scikit image library. But if I'll talk about now, so we are trying to use basically ONNX, we are trying to use a TensorFlow, we are trying to use a PyTorch. So that's a difference you will be able to find out. And accuracy wise, so there was not much of accuracy, there was not much of a big problem which we were able to solve in a traditional computer vision. But yeah, with the help of this modern one, obviously we are able to solve a lot of things. Now, so when I'm talking about this modern and traditional, so let's also talk about that what kind of a problem in general we try to solve with the help of a computer vision. So the very first problem that we try to solve with the help of computer vision is called as image classification. image classification. Now, what is this image classification, by the way? So here, if you will go to maybe like Yuri, and then if you are going to ask a question, let's suppose, or maybe, yeah, I'll go to Yuri and I'll just go for a GitHub search. I say that image classification official repo. So maybe it is going to give me some sort of a repo, right? So where I can try to show you some of the images from an official repository that, okay, so this is something called as basically a image classification. So OpenML Lab, image classification, Facebook search. So here, okay, so there is no images which I can see here. Maybe I can see some images in this place. Okay, just do one thing. So let's go to Hugging Face and then models and then image classification. So maybe I can try to use any of these like models, which is an inbuilt model. And again, don't worry about it, right? So don't worry about it like how we are going to use all of these things. I'm going to teach you and I'm going to tell you that how to use all of these things. So here you will be able to find out a tons of models, right? Tons of models. And here, if you're going to search, you will be able to find out a tons of repository, maybe some of the repository from some of the individuals, maybe some of the repository from some of the official companies. So you will be able to find out that many people have built a lot of image classification models. So what it does, so wherever you are going to pass an image, it is going to tell you that, okay, so this image belongs to this class or that class. Maybe I'm going to pass my image and my friend's image. So it is going to give me a label saying that okay, this is a Tanshu's image and this is a Tanshu's friend's image, right? So this is something called as image classification. Now we have a better and better model which is available. But again, so if I have to train my model based on my custom data, based on my custom label, so obviously I have to train it from the scratch. So maybe I can try to use a fine tuning. Maybe I can try to train a model from the very scratch by creating my own network architecture. And that is something that we are going to do inside a class. Now that falls under a image classification. Yeah. So where you try to predict a label by passing an images and system learns that, okay, so if this is a set of the images which I have received, this belongs to this class A, class B, class C. So image classification is one of the problem statement that we try to solve. And again, to solve this problem statement, so we have a multiple models out there. For example, we have something called as LXNet, we have LeanNet, we have a ResNet, ResNet 50, we have VGG, we have a DarkNet, we have EfficientNet. So a lot of model you will be able to find out, a lot of architecture you will be able to find out which is out there for solving this particular problem. But again, so it's not like we should use all the architecture at a time, and it's not like just one we are going to learn and that is going to work for all the problems. So no, there are a lot of variables which comes in between, right? A lot of variables when we try to solve a real-time problem. So accordingly, we have to choose the architecture. So image classification is one of the problem that we are going to solve. Now, the second part is the problem that we try to generally solve with respect to a computer vision is called as object detection. Object detection, right? This is the second set of widely used problem. For example, so let's suppose if I'm going to take a frame, right? If I'm going to take a frame and then inside this frame, so we have multiple people, multiple different kind of like a object which is available. Now, if I have to identify that, okay, so this is basically a person A, this is person B, this is another object which is available inside the image, that is called as object detection. So again, widely used problem. Because just imagine that we are trying to solve or we are trying to build something for a computer vision, self-driving car, right? Now, so self-driving car will keep on taking a stream of the data. It will keep on taking those feeds. Now, so it should see the image. It should like see the images. It should identify that what is there inside the image. So for example, if there is a pedestrian, if there is maybe some living things, it should not pass that particular part, right? Or it should not surpass the living things. It should stop. It should like maybe divert. It should stop. It should maybe take a different route, a different path. But yeah, if there is a non-living things, it should maybe like surpass those non-living things. So to do that, it has to identify just like a human being, right? So we have a sense. We know that when to stop and when not to stop, right? So in the similar manner, your self-driving car, autonomous car is supposed to do the same thing. Now, how it can be done? So with the help of identifying the object. And this is where object detection comes into a picture. It's one of the complex problem, right, to solve. Again, so if I'll talk about security and surveillance, detection is a very important part. So object detection is something that we try to solve. Now, the third problem in general that we try to solve is basically called as image segmentation. Image segmentation. Now, what is this image segmentation, by the way? So image segmentation is again a kind of a problem. So where we just try to create an outline of the entire image. The outline of the entire images we try to create. For example, nowadays you must have seen in a mobile application that if you're going to double tap on your picture, it will remove all your background. It will just keep you, right? You must have seen that. Now that is something called as again a segmentation. So it is able to identify the entire outline. Now, if I have to show you maybe with respect to the image segmentation, let me find out some images, by the way, guys. It must be available somewhere. Yeah, no, this is not a segmentation image, by the way. Yeah, so here you must be able to see that there is this image, right? So there is this image, and here, so you will be able to find out that out of this entire things, people are able to segment just a part of the images. They are able to take out the part of the images, right? They are able to take out. Now this is something called as image segmentation. Yeah, maybe from a video, maybe from a static images. So this is something called as image segmentation. And again, that is one of the big problem that we try to solve all the time. Just as you can see, like this one is also image segmentation that you must be able to find out. Yeah, so we are segmenting the complete images. Again, there are different kind of image segmentation which exist, and we are going to learn that how to solve those problems basically with the help of some of the inbuilt model, or with the help of some of the model that we are going to train from the very scratch. So this is another problem that you will be able to find out, segmenting the images. Now, the fourth problem that we try to solve in general as a part of computer vision is called as basically object recognition. For example, a facial recognition. So recognize this object, identify it, recognize it, right? So that is one thing. The another part that we try to solve over here is called as pose estimation. Pose estimation. Let me show you some of the repo with respect to pose estimation. There are some interesting repos which is available out there. Even inside a Hugging Face, I believe I can find out some of the images. So object detection, depth estimation is fine. Then the pose estimation. Okay, let me pose. By pose estimation, yeah. So maybe you can just go and you will be able to find out a tons of repos and models which is been designed. So they have not uploaded a picture over here. So maybe I can try to see their reference somewhere. View PDF. Yeah. So this is basically called as pose estimation, guys, as you can see, right? So a different kind of a pose, different kind of a points on your body, and based on that, as you can see, right? So it will be able to identify the pose. So whether I'm folding my hand, I'm doing some sort of a yoga, some sort of a namaste, pranayam or something. So I will be able to identify it, and it is having a lot of use cases, right? In terms of building some of the retail or commercial purpose use cases, in terms of building some of the strong surveillance system. So where I will be able to identify the object in a person's hand, I will be able to identify that what kind of a pose person is having. So whether it's a pose which is going to threaten someone, or it's a friendly pose, many things, right? Many application you will be able to find out with respect to a pose estimation. So a lot of problem that we try to solve even with respect to pose estimation, and lot of models are already out there. So which is very good in terms of estimating a pose, right? So you can go to again this one, Hugging Face, and you will be able to find out these things. Yeah, you will be able to find out. See the pose. Yeah, the pose. So we are going to even see these kind of models in our learnings in our study. Now, so this is one of the problem that we try to solve, pose estimation. The another problem that I would like to highlight over here, likewise there are multiple problems, but yeah, so I'm just trying to highlight a major problem over here. Tracking. So there is a big problem called as OBJECT, object tracking. So the way we as a human being can track any object movement from one place to other places, but at the same point of a time, it gets very much difficult for a machine. The reason is that we as a human beings, our brain is very much intelligent, and we can take a complete we keep on taking a continuous feed, but at the same point of a time, for a machine, so it's basically a set of the or frame of the images. Video is also, when you are trying to stream the data, it simply means that you are trying to send a frame by frame data, right? This is something called as streaming. Yeah. So it is like so for a machine, so it is supposed to identify something in every object, so every frame that you are going to send, plus it is supposed to connect all the dots, right? Connect all the dots, then only it will be able to track it in even one single frame. If someone is going to alter something, it will lose the track. Plus so in a shopping mall, or maybe in a crowded area, or in any area, I would say, so if I had to track a person which is moving from one camera to another camera, so again that's a problem, right? Again that's a problem, because we as a human, we can remember that person has moved from this place to that place, if we are looking at that person movement. But as a like a system, as a hardware, so obviously as a camera, so someone camera is trying to capture some of the feed, and some other camera is trying to capture some other feed, some other streams, and you have to correlate between each other, right? So it's one of the advanced problem. It's one of the hard problem that we try to solve, and that is something called as object tracking. So object tracking inside a single camera, object tracking with respect to a multiple camera feed. So a very, very tough problem to solve. People are still trying to solve this particular problem. Again, there are some solution which is available. Even we have built that, and we are going to see a couple of things even with respect to the object tracking, that how we can keep track of the object at the end of the day. So these are the tasks, guys, in general we try to solve. Apart from that, there are many tiny tasks that you will be able to find out. But yeah, so these are the major tasks that we are going to find out. Now, so if I'll talk about a core library, so I think in my roadmap section, I have already introduced that part, that there is a library called as OpenCV, which is going to help you out in terms of like doing some sort of a data cleaning operation on top of the images, maybe some sort of a modification operation. But at the end of the day, we will be using a TensorFlow, we will be using a PyTorch. Yeah, we'll be using a TensorFlow, we will be using a PyTorch, and based on that, so we are basically like going to build a model, or we are going to like fine tune the model, we are going to retrain the model. Depends upon the task that we are going to pick up in your class when we will go through the class. But yeah, believe me, it's one of the very, very interesting field, and when you will see the result, right, when you will see the result, you will be amazed. And in class, that is something that I'm going to do, right? So you are going to feel very, very amazing and exciting. So with that, let's get started with the exciting journey, guys, and let's try to learn all of these applications, and let's try to solve all of this problem with respect to a computer vision in a step-by-step manner. And let's build something. Let's build some application, an amazing one, an innovative one. So with that, thank you so much, everyone. Take care, and see you again in my next lecture.